So we are using high and low method. So high-low method means you will be given like 2 points of your production. Right, 2 points of your production, and you need to find out the difference, and then you need to find out the V first. So let's try to do is 6, 8. 6, 9, sorry. 6, 9. Let's read the problem first. I think it's fine, but if it's too much light, you can tell me if you have any problem to read it. Maybe I can just... So, what is the cost equation? Who can help me? What is the cost equation? Cost equation. Cost equation. Yes, Aiden? I'm writing the cost equation Vx plus F. Now let's see. Gianna, Y? Y stands for? Gianna, C. Y stands for? Y means what? Total cost. V means? Variable cost per unit. X is? X means what? Yes, Kyle. Number of units. F means? Fixed cost. Jason, good. So first we will figure out what is our V. And I just erased that part. V means kind of the slope of your cost line. Right. How steep your line is. But I just erase it. V is kind of a fraction. Which fraction in your numerator, which is the upper part, it says changes in cost. Changes in cost. This is the delta sign. Changes in cost. And your lower part, which we call denominator, is changes in volume. Right. Now, what do you mean by it? And for that, we need to read the problem carefully. So it says that Barnfield Catering uses high-low method to predict its overhead cost. Past records show that total overhead cost was $25,600 when the company worked for 860 hours. And then they have another point of their working schedule. So it says that they have their total cost, overhead cost, $27,800 when they work for like 960 hours. So you see, you have like 2 points. One is highest point of your working hours or highest point of your production or whatever, and another is your lowest point. So that means the second line, you work for 96 hours. That's your highest point of your working. And that time you had like this cost, 27,800. So what we do, we will take these 2 points of productions, and for our numerator, we're going to show the cost difference. For our denominator, we're going to show the volume difference. Here our volume is hours. So in our numerator, let's try to do the cost difference. So for highest number of hours that we worked, which is 960. What is the cost when you work 960 hours? The highest number of hours you work 960, and your cost is 27,800. Right. That's your high level of production. And then when you work for 860 hours, what was your cost? What was your cost? Yes, Paul? 25,600. So you have 2 points of production, and you know the costs for those 2 points. So for your upper part, you're going to take the difference. So I took the difference. For your lower part, we're going to take the difference for our volume. So upper part is the cost difference, lower part is the volume difference. So here, which one actually drives our cost? Number of hours, right? So we're going to take the difference between these 2 production point or 2 hours. One is 960, another is 860. Everyone, please use your calculator and tell me the numbers. What is your denominator? Quick, we need to do one more. Denominator. Yes, Paul, you have numbers? Please. 2,200 and numerator 100, and this is how you got how much? 100. 22, right? 100, 100, 0, 0 cancel out. So this 22 is our V. V means what? V means variable cost per unit of your volume, per unit. That means if you work for 1 hour, your variable cost will be 22 bucks. So depending on how many hours you work, that would be your total variable cost. So we just solve for letter V, which is our variable cost per unit. Now we will try to figure out letter F. F is our fixed cost. Now we need to do a little algebra, right? So we know what is our cost equation. So I'm writing the cost equation again here because I want to plug in some numbers and solve for F. So now just pick one point of your production. Either you can pick like your highest number of hours, which is $27,800 cost and 960 hours. Or you can pick the lowest point of your production, which is $25,600 and your working hour was 860. It's up to you. You can pick any point. So let's try to pick the first point where you work for 860 hours and your cost is 25,600. Right, so let's pick this one. You can pick any one and you will get approximately same result. So I'm just picking this first point of our production. And now I'm going to plug in the numbers. 25,600, this is our cost, total cost. So that means it's the value of Y. So if I plug in all these numbers, our Y is 25,600. Now we just solve for V. V is how much? V is what number? V? 22. So I'm writing V here, 22. V, X means V multiplied by X, times X. Okay, these two together means times. So I'm multiplying it by X. X is our volume, which is here hours. So for $25,600 cost, you have to work like 860 hours. That means for this 25,600 cost, your X is 860. So for X, I'm going to plug in 860. Now we actually don't know F. So F is unknown. So that's the little calculation you need to do to solve for F. So how can you do that? If you can remember all those algebra that you did in your middle school or high school, you should be fine. So that's 25,600, and if you multiply these two, how much? Can anyone tell me if you multiply? Yes, Courtney, please. 18,000. 18,920 plus F. Now we need to solve for F. So there are two sides for it. For this equation, you have left-hand side, another is right-hand side. So you can change the sides. So say if you change the side, the sign will be changed, right? So for example, if you, I'm just writing this one here for your clarification. I'm trying to be very detailed, 600. So now I'm going to change this number and I'm taking it to the other side. So if you take this 18,920 from left side to right side, it's a positive sign. You have to make it negative. So I'm subtracting it, 18,920, and this is how I got F. F is how much? F, yes, Eden. You got 680. Is this the F that all of you got it? Can you check it? This is 25,600. I subtracted 18,920. Is that the F? 6680? Good. Colin, you also got this. So I have now a V, I have now F. Now I can write down our standard cost equation. We know cost is this equation. Now, standard cost equation, V is 22 times whatever is your production volume, X, and F is 6680. So this is your cost equation. Once you know your cost equation, for any number of hours or any number of production, you can figure out your total cost. So this is your cost equation. So first you need to figure out your V, then you need to figure out your F, then you need to write down the cost equation. Now, if you read the last sentence, read the last sentence. It says, if Brownfield Catering has 885 hours scheduled for next month, what would be the expected overhead cost? So next month, they are expecting to work for 885 hours. What would be your total cost? So you know your cost equation. You know your X. X means how many hours. So if you plug in the X value, you will find your Y. Y means your total cost. So for next month, our X or number of hours is 850. Now you know your cost equation. So you're gonna plug in the value of X. So I'm writing the cost equation again. Y is equal to 22X times 6,680. So now we know how much is our X. X is 885. And you know V, you know F. So if you do this little calculation, you will find Y. Y means what will be your total cost for next month. So who has the number, please? Y. Y, Mackenzie? Bless you. Bless you. 26,150. So you see the steps. First, I try to figure out V. Kyle, is that fine for you? I know you two sit there. It's hard for you to see the board because of the light reflection. Let me check. I guess better. Is it better for you guys? Okay, good. So that's no problem. So that's what we did. Don't sleep. We still have a few more minutes. Okay, I know I turned off the light. First, you're going to solve V. Then you're going to solve F. Then you will plug in here. You know the cost equation. Then, for your future prediction, you can figure out your cost. Right, so that's what we did. And this is called high-low method because you are considering only 2 points of your production. One is your highest production, another is your lowest production. Now we're going to do the same problem, but a little different format. We're going to do another high-low method, okay? And for that one, you need to figure out the same thing, V, and then we're going to do F. Then we will figure out what is our cost equation. And then finally, if you need to do any prediction, you can do that. And the next day's homework problem, I'm just passing it in case we rush at the end, is exactly like the same problem what we are going to do now. Okay, so I'm passing next day's homework too. Once you are done with this problem today, I hope all of you will do the homework and bring it next class. Okay? So now you will get the same problem for your homework next class. So we're gonna do E634. E634A. Again, it's the high-low method. We're going to do the same thing. First, calculate V, then F, then cost equation. Right, but here, you will see here, you have like several months. You have several production points. In your previous problem, you just had 2 production points. But now you have 1, 2, 3, 4, 5, 6 production points. And for 6 different production points, you have different costs, different hours, machine hours. That's totally fine. We will try to focus on our highest production and lowest production in terms of our volume. That means our here, which one is the cost driver? which one incurs cost? Which one is the cost driver? Machine hour is the cost driver. So if you read the problem, it says Somerville Company, which uses the high-low method to analyze cost behavior, and they has determined that machine hours can predict the company's utility cost. So machine hour is the cost driver, right? So they have here for first 6 months different machine hours, and they have different costs. So first, what we do, we will try to pick our highest volume of machine hours. Right, so we're going to pick our highest volume of machine hours. So this one is the highest. In the month of June, their machine actually ran for 1,480 hours. This is their kind of highest amount of machine hours. And which one is the lowest amount of machine hour? Which month they have lowest hours? Which month? This is very hazy, but you can check your own table. Which, February, I think it's March, right? Isn't it March? Because it's 1,080. February is 1,120. So March is the lowest number of machine hours. June is the highest number of machine hours. So one is high, another is low. So we're going to take these 2 points, June and March, and we'll do the same thing. So don't be confused to see like 6 months, 6 numbers, 6 costs, 6 hours. We will do the same thing, but we're going to take only our high volume of hours and low volume of hours. So let's try to do it. I hope, yes, good. We have enough time. So let's try to do E. 634A. Write down the cost equation. Y is equal to Vx plus F. We all know Y means total cost, V is variable cost per unit, X is your number of hours, or yes, Paul? Usually you should pick highest and lowest. But you know, you can pick any too much randomly. You will get like approximately like picking highest and lowest, not get never pick highest and lowest. You want kind of average costing. Good question, Paul. You can pick any 2 points, but every time you're gonna get kind of approximation, and you will be fine. You will be fine. Even for your real life, you can, if you take any 2 points, even taking high and low, you may not get your accurate cost. That's the disadvantage. Good. So now first try to figure out V. V means in your numerator, you need to show the changes in cost. That means the cost difference. And your denominator, you need to show the changes in volume. Volume. That means we selected 2 points. Right. And 2 points based on your machine hours, because machine hours is the cost driver. The more number of hours your machine will be running, the higher will be your cost. So for June, for the month of June, your machine worked for the highest number of hours, which is 1,480 hours. And your cost was how much? So I'm going to show the cost highest, approximate highest cost based on your highest machine hours, which is 4,192, and the lowest one for your 1,080, which is in the month of March, and your cost was 3,532. So I'm showing the cost difference as my numerator and the volume difference. For this case, it's our machine hour as my denominator, which is 1,480 minus 1,080. And if you do so, you should figure out your V. So can anyone tell me what is V, Courtney? 4,800, which one you use? Oh, you pick the cost, right? Based on your cost. Yeah, Courtney's question is also correct. You know, Courtney said that she didn't look at the machine hours. She picked like based on the cost, right? Because 4,800 is the highest cost. So you thought this is the highest level of your production. You could also do so. You will get slightly different answer. But that's fine. So pick the highest and lowest, either based on your hours or based on your cost. Right, you will get slightly different numbers. But that's fine because this is your highest point in terms of cost. But it's better if you consider your high and low point based on your volume or hours. Right. So if we do so, who can tell me the number, or I can give very detailed. What's the difference here? Numerator. Who can tell me? Very quick. If you finish quickly, you can leave early. So it's 660. And what's the difference of your machine hours? 400. And if you do so, your V is? How much? 1.65. Good. So 1.65 is your V. This is your variable cost per unit. That means if you run your machine for 1 hour, the variable portion of your cost is 1.65. Again, you can pick two high and low points based on your cost. You will get slightly different numbers. But if you follow the method accurately, you will get points. But it's better if you pick the high and low based on your volume or X. Now we're gonna do the F part. So I will pick any point. Either you can select your highest point or lowest point. Just plug in all those and solve for F. So our cost equation is Y is equal to Vx plus F. And take any point. It's up to you which point you want to take. Say, for example, if I want to take highest point. Highest point of ours is 1480. That's our X. And for that 1480, which is in month of June, our Y or total cost is 4192. So I'm taking the month of June. It seems that's the highest. You can pick any point. So Y is for June. Y is how much for June? For June, Y is how much? 4,192. Great. And V, we got V how much in our previous part? 1.65. And for June, our X? Excellent. 1480. And now you can solve for F. Right? So, can you tell me this number first? I'm just trying to do every step. This number. You didn't get it? Yes, Mackenzie, please. 2,442. Excellent. And F. Now solve for F. If you take the lower part here, you need to change the sign. Right. I'm just trying to be very detailed so that you don't be confused. And F 4192. I'm taking this 2442 from our left side to right side, and I'm gonna change the sign, and it gives me F. F is how much? 1,750. Great, that's my F. That's my V. Now I can write down my cost equation. A standard cost equation is Y is equal to 1.65x plus 1750. This is my cost equation. So now you can figure out any cost depending on how many hours your machine will run. That means whatever is the X, the machine hours, you can plug in and you can figure out Y. So first step, find V, which is your variable cost per unit. Then solve F, which is your fixed cost. Then write down your cost equation. And then you can figure out for any number. So requirements 1 says, what is the variable utility cost per machine hour? It's 1.65. Then what is the fixed cost? It's 175. Again, all these are approximation. If you select two different points, you will get slightly different numbers. Right. Now, number 3 says, if Somerville Company uses 1210 machine hours in any month, what will be its total cost? Now, you know this cost equation. Now, 1210 machine hours, right? For any month, your machine will run for 1,210 hours. That means your X is 1210. What will be your Y? 1.65 times 1210 plus 1750. 1,750. 1.65 times 1210 plus 1750. What is your Y? 1.65 times 1210 plus 1750. 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 calculator with them? Danny and Hannah, Kyle, you have your calculator, everyone? Joe, Matt? Where is your calculator? You are here, right? You are alive. So your calculator should be here. Okay, let's see, Nina. What is your Y total cost? Okay, so you can round it 3,740. 6 point something, right?
Yep.
Okay, 0.547, whatever. So you can round it. Okay, so that means if your machine runs for 10 hours for any month, this will be your total cost.